want to go over some examples from section 9.4. The chapter is about, or this section of the chapter is about simplifying rational expressions. That I want to go over are number 5, number 11, and number 17 on page 511. And for number 5, the directions say, simplify each rational expression, state any restrictions on the variable. And you're given this problem here, 2x plus 10 divided by x squared plus 10x plus 25. The first thing that you need to do before you state any restrictions on the variable is you need to simplify the rational expression, and what you're going to do is take out any common factors. So the first thing that you need to do is factor the numerator, and then you need to factor the denominator, and you need to note any restrictions first, then take out any common factors. So 2x plus 10, we can take a 2 out, a factor of 2, out of both of the terms, leaving you with 2 times the quantity x plus 5. Those are your two factors in the numerator. 2 is a factor and x plus 5 is a factor. Then if we have x squared plus 10x plus 25, that factors to x plus 5 times x plus 5. The restrictions on the variable will be any variable that makes the denominator go to 0, which really means any number that will make the variable in any of the factors, any number for the variable that will make any of the factors in the denominator go to 0. So in this case, in this particular case, they happen to have the same restriction for each of the factors, because x cannot equal negative 5 for x plus 5, and then for the second x plus 5, x can also not equal negative 5. After that, you simplify by dividing the numerator and the denominator by x plus 5. In essence, x plus 5 divided by x plus 5 becomes 1, so you're left with 2 divided by x plus 5. That is the rational expression that we're giving in simplest form, and the restriction is that x cannot equal negative 5. If you look at number 11, you're given, just move it up a little bit, you're given x squared minus 4 divided by x squared minus 1 times x plus 1 divided by x squared plus 2x. And again, you're going to go through the same process. You're going to first factor the numerator and the denominator. You're going to factor the other numerator and denominator. You're going to note any restrictions there. Then you're going to take out any common factors that you have in the numerator and the denominator. So let's look at x squared minus 4. That factors to x plus 2 times x minus 2. If you go to the denominator, x squared minus 1 factors to x plus 1 times x minus 1. If you look at the other fraction, you have x plus 1, that's already factored in the numerator, and then x squared plus 2x factors to x times x plus 2. Now let's note any restrictions. In other words, any numbers that will make the factors go to 0, because if the factor goes to 0, then the whole denominator goes to 0, and you cannot have division by 0. So those are all restrictions in the domain. So x cannot equal negative 1, because negative 1 plus 1 equals 0. X cannot equal 1, because 1 minus 1 equals 0. X itself cannot equal 0, because x is a factor. And then x cannot equal negative 2, because negative 2 plus 2 equals 0. So those are all your restrictions in the domain. Then you can take out common factors, but you do not, when you do that, you do not eliminate any restrictions that you have already cited for the domain. So in the numerator, we're just left with x minus 2. In the denominator, we're left with x times x minus 1, because you can divide the numerator and the denominator by x plus 2. You can also divide the numerator and the denominator by x plus 1. Now let's look at number 17. Number 17, because you have the division of rational expressions, what you have to do is you have to factor each rational expression in the numerator and the denominator. Note any restrictions. Then you're going to multiply the first rational expression by the reciprocal of the second rational expression. You're going to note any restrictions there, Then you're going to simplify, and when you simplify, you do not get rid of any of the restrictions. The restrictions still remain. So we start with x squared divided by x squared plus 2x plus 1, and that's all divided by 3x divided by x squared minus 1. The numerator in the first fraction is already simplified in the first rational expression. The denominator in the first rational expression is factored to x plus 1 times x plus 1. The second rational expression, we have 3x is already simplified, and we have x squared minus 1 factors to x plus 1 times x minus 1. So our restrictions are x cannot equal negative 1 and x cannot equal positive 1. Now we invert the second fraction, or we take the reciprocal of it, and we then look for any restrictions. Because now 3x is in the denominator, x cannot equal 0. So we have three restrictions. X cannot equal negative 1, x cannot equal 1, and x cannot equal 0. We can simplify this, and you'll see that you can divide the numerator and the denominator by a factor of x plus 1, leaving you in the numerator with x squared times x minus 1, and leaving you in the denominator with x plus 1 times 3x. I rewrote that as 3x times x plus 1. And again, our restrictions are that x cannot equal negative 1, 1, or 0. If you have any questions, let me know. I thought that I was going to be in school today. Obviously, I'm not. So be safe during the snowstorm, and I will talk to you as soon as possible. If you have any questions at all, email me. Have a great day.